In the previous task, we saw the changes that might encounter the equilibrium distribution curve, given pressure or temperature changes. Now, I want to compare several materials, not only the temperature pressure effect on the same one. And I have selected this graph, which is, I think, good enough to see how different materials should and will not have the same solubilities in the same solvents. So here, mole fraction of the solute, which in this case will be SO2, ammonia, and hydrogen chloride in water. Now these, as you can see, most of them 10 Celsius, 10 Celsius, and 10 Celsius. Solubility depends on a lot of things, especially in gases, but as you can see here, there are plenty of hydrogen which will form hydrogen bonding in water. They are also very polar. And if you compare SO2, well, it's not that polar, therefore you should not expect that much sulfur dioxide in water. Also, the temperature effect, if you remember, solubility typically decreases as temperature increases. So you can see here the mole fraction, this is solubility for the given case at temperature 10 Celsius versus 30 Celsius, you will see that there is a decrease in solubility. Probably you are wondering why we have the same amount of X, but for the same amount of X we require a greater amount of that gas in the vapor phase, meaning that we require a higher partial pressure to achieve this solubility. Okay, we already compared the different species and vapor pressure of each material. Relatively insoluble gases, we already said that maybe oxygen, nitrogen, air, and so on can assume to be gas phases. And also, if that's true, their partial pressure must be very high, meaning that because we don't have that much nitrogen going to the liquid, the pressure of nitrogen, or the partial pressure of nitrogen, should be higher compared to, I don't know, ammonia, which will be in both gas phase and liquid phase. High soluble gases have lower partial pressures. Okay, try to get that. Ammonia should have lower vapor pressure, partial pressure, because it can go in the gas phase and the liquid phase. In many practical cases, only one component in the gas mixture will be considered soluble in the liquid. So far, I didn't want to tell you, but technically speaking, air, or nitrogen or oxygen, will in fact be soluble in water. But the amount is so small compared to ammonia, this is very high in solubility, this is very low in solubility, that you can assume that these are partially or technically non-soluble in water. Here it goes. The ammonia, air, water system, recall that ammonia is very soluble. You will expect that the partial pressure of air, or oxygen and nitrogen of course, will be much, and I don't like to use only one, it's much greater than the one of nitrogen, or sorry, ammonia. So that's the main idea, guys. Whenever we talk about gases, this will be a gas which is not that soluble, compare versus not soluble versus a gas which is very soluble.